Ever wondered how a QA manual tester ensures the software you use is flawless? Let's dive into that. QA manual testers, or quality assurance manual testers, play a crucial role in the software development process. They are the guardians of software quality, ensuring that the end product is free from defects and operates as expected. At the heart of their work lies software quality assurance and control. This involves a series of systematic activities designed to ensure that the developed software meets specific quality standards. It's all about preventing faults in the first place. But if they do slip through, it's the tester's job to find them. So, how do they do it? Well, there are different types of manual testing techniques that a QA manual tester employs. Let's touch upon a few of them. Firstly, there's black box testing, where the tester doesn't need to know the internal workings of the software. They just need to know what the software is supposed to do. They input data and observe if the output matches the expected result. Then there's white box testing. Unlike black box testing, this requires a deep understanding of the software's internal logic. It's like having a map of the city while driving instead of just following road signs. There's also gray box testing, a mix of both black and white box testing. Here the tester has partial knowledge of the internal workings of the software. Each of these approaches has its strengths and weaknesses, and a good QA manual tester knows when to use each one for maximum effectiveness. QA manual testers are the unsung heroes who ensure your software experience is smooth and error-free. They work behind the scenes, meticulously testing each function, each feature, to make sure that when you click on something, it does exactly what it's supposed to do, every single time. Stay tuned as we delve deeper into the world of QA manual testing in the next scene. What happens when a tester finds a bug and the developer insists it's not a bug? This is a common scenario in QA testing. In the world of quality assurance, or QA, disagreements can often arise over what constitutes a bug. At times, a tester might identify an issue only for the developer to insist it's a feature, not a bug. So how should you handle this situation? First and foremost, maintain effective communication. It's crucial to establish an open dialogue with your developer. Discuss the issue at hand, explain why you believe it's a bug, and listen to their perspective. Remember, it's not about winning an argument, but about ensuring the best possible product. Next, rely on thorough documentation. In the realm of QA, documentation is king. If you've documented the issue well, with clear steps to reproduce the bug and its impact on the software's functionality, it will be hard to dispute its existence. Screenshots, video recordings, and detailed descriptions can all be incredibly useful here. However, there may be instances where the disagreement persists, despite your best efforts. In such cases, don't hesitate to escalate the issue. Bring it to the attention of a project manager or a team leader. They can offer a fresh perspective and mediate the disagreement. You see, in QA testing, it's not about proving who's right or wrong, it's about identifying and fixing issues to ensure a high-quality product. So, if you find yourself in a situation where a bug you've found is being disputed, remember these steps. Communicate effectively, document thoroughly, and don't be afraid to escalate when necessary. Remember, the goal is to get the bug fixed, not to prove who is right or wrong. Now let's talk about functional and non-functional testing. Wondering what these are? Stay tuned. Functional and non-functional testing are two key types of software testing. They are like two sides of the same coin, each playing a vital role in ensuring that a piece of software is up to snuff. So, what exactly are they? Functional testing is, in essence, a type of testing that validates the software system against the functional requirements. These requirements are the functions that a system is supposed to perform. So for instance, if you've got a calculator app, a functional test might verify if the addition function adds two numbers correctly. It's all about ensuring the system does what it's supposed to do. On the flip side, we have non-functional testing. This type isn't concerned with the functions of the system, but rather with how the system performs those functions. It's all about the how, rather than the what. Non-functional testing could involve checking how fast the calculator app performs the addition, or how well it handles a large number of simultaneous calculations. It covers aspects like performance, reliability, usability, and so on. Both functional and non-functional tests are crucial in their own right. Functional testing ensures the software works as expected, validating the core functionalities. Without it, you might end up with a calculator app that multiplies when it should be adding. Non-functional testing, meanwhile, ensures the software meets certain standards and expectations in terms of performance, security, and user experience. Without it, your calculator app might work fine. But if it takes 10 minutes to add 2 and 2, users are likely to abandon it for a faster alternative. So both functional and non-functional testing are important for different reasons. Together, they ensure a well-rounded examination of the software. Ready to dive deeper into functional testing? Let's go! Functional testing is a type of software testing where we confirm that each function of the software application operates as per the requirement specification. It's like being a detective, making sure every clue, or in this case function, leads us to the right conclusion. Let's kick things off with unit testing. This is the first level of functional testing where the smallest testable parts of an application, known as units, are individually scrutinized for proper operation. Think of it as inspecting each piece of a puzzle before putting it together. For example, if we're testing a calculator app, we'll check if the addition function correctly adds two numbers together. Next up, we have integration testing. Here, individual units are combined and tested as a group. This is done to expose faults in the interaction between integrated units. It's like putting together sections of our puzzle and checking if they fit seamlessly. For instance, in a music streaming app, we might test the integration between the search function and the playlist creation function. Then comes system testing. This is where the entire system is tested to verify that it meets the specified requirements. It's like finally putting all the puzzle pieces together and seeing the complete picture. Using our music streaming app example, we would test the entire application, including searching for songs, creating playlists, and playing music, to ensure everything works together harmoniously. Finally, we have user acceptance testing, often called UAT. This is the final phase of testing where the software is tested in the real-world scenario by the intended audience to validate the usability, functionality, and compatibility of the application. It's as if you're presenting the completed puzzle to be admired. If we stick with our music streaming app, UAT would involve actual users testing the app in their everyday lives, playing their favorite tunes, and creating their unique playlists. Each of these types of functional testing plays a crucial role in ensuring that the software functions correctly, from the smallest unit to the entire system, and in the hands of the end user. Functional testing is all about ensuring each part of the software works as it should. It's like checking if all the pieces of a puzzle fit together perfectly. Ever wondered how SQL is used in QA manual testing? Let's find out. SQL, or Structured Query Language, is an integral part of QA manual testing. It allows testers to interact directly with the database, retrieving or manipulating data to ensure the software functions as expected. Imagine you're testing an application that stores user data. You may need to verify if the data entered through the application's UI is being correctly stored in the database. This is where SQL comes in handy. By writing simple SQL queries, you can fetch the data from the database and cross-verify it with the input data. Now let's have a look at some common SQL-related interview questions and their answers. One typical question is, what is an SQL join and what are its types? An SQL join is a method to retrieve data from two or more database tables based on a related column between them. The types of SQL joins are inner join, left join, right join, and full join. Another common question is, what is the difference between delete and truncate commands in SQL? The delete command is used to remove specific records from a table, whereas the truncate command is used to delete all the records from a table and free the space containing the table. A third typical question is, how would you retrieve the top 3 records from a table? You can use the SQL statement, select asterisk from table underscore name order by column, underscore name deci limit 3 to fetch the top 3 records. Remember, these are just some of the questions you might face in an interview. SQL is vast, and its applications and testing are extensive. So, make sure you have a good understanding of SQL commands, queries, and operations. SQL is a powerful tool in a tester's arsenal. It helps testers view, query, and manipulate the data to ensure everything works fine under the hood. What's a test plan and test strategy, and why are they important in QA manual testing? Let's explore. Diving into the world of software testing, you'll come across 2 critical documents, the test plan and the test strategy. So, what exactly are these? A test plan is a detailed document that outlines the testing scope, activities, timelines, priorities, and resources required. It's like a blueprint that guides the testing team on what to test, when to test, and how to go about it. On the other hand, a test strategy is a high-level document that defines the approach to be taken during testing. It sets the standards and guidelines for all testing activities and aligns them with the project's objectives. The test strategy helps in making informed decisions about the test techniques to be used, the testing tools needed, and the risks and contingencies to consider. Now, why are these so important in QA manual testing? Well, think of them as your GPS during your testing journey. Without a test plan, the team could lose focus and miss out on testing some critical aspects of the software. It helps in defining clear objectives and ensures that all team members are on the same page. The test strategy, on the other hand, is like the compass guiding your testing efforts. It helps in maintaining consistency in the testing approach across different team members and projects. It ensures that the testing process aligns with the business objectives, thus improving the overall quality of the software. In a nutshell, a test plan and test strategy work hand in hand to ensure a smooth and effective testing process. They help in identifying potential challenges and risks in advance, allowing the team to prepare and respond effectively. Remember, the key to successful testing lies in meticulous planning and a well-defined strategy. Without these, the testing process could become chaotic, leading to missed bugs and defects that could severely impact the software's quality. A well-crafted test plan and test strategy are like a roadmap for testing. They guide testers on what to test, how to test, and when to test. We've covered quite a bit today, haven't we? Let's do a quick recap. We began our journey with the role of a QA manual tester, emphasizing the importance of this position in maintaining the quality of software products. We delved into the challenging yet rewarding task of identifying and rectifying software bugs, and how to navigate the tricky waters when a developer disagrees about the existence of a bug. Then, we moved on to the broad categories of testing, functional and non-functional. We highlighted that functional testing is all about ensuring the software performs as it's supposed to, while non-functional testing focuses on aspects like performance, usability, and security. We took a deeper dive into functional testing, exploring its various types and their importance in maintaining the software's functionality. We also touched upon the role of SQL in QA manual testing, and how SQL skills can help in data validation and manipulation, enhancing the tester's capabilities. We discussed how mastering SQL can give you an edge in your QA career. Then, we delved into the critical aspects of test plan and test strategy. We explored how a well-crafted test plan provides a roadmap for the testing process, while a comprehensive test strategy outlines the overall approach to ensure the quality of the software. QA manual testing is a fascinating field, isn't it? Remember, every bug you find and fix makes the software better for its users. Keep testing, keep improving.